Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is IGCSE Physics, uh, this is Standard Physics, and the code for this subject is 0625. Today we are solving its paper 4, and we have selected October-November 2023 4-3 paper. This paper 4 belongs from the Zone 3. So in this video, we are going to attempt its question number 5 of this paper. This question is related with the topic diffraction. Diffraction is the new topic which is added into the Cambridge O-levels physics syllabus. So we are doing this video. Why we are doing this video? Because this is the new topic which has been included into the syllabus for Cambridge O-levels physics 5054. And we are collecting these questions from IGCSE for our students of the Cambridge O-level. So without further ado, let's start this paper. Okay, so we are going to attempt this question. This is question number 5, and it's a very important question. He says, figure 5.1 is a scale diagram of wavefronts of red light approaching a gap in a barrier. On the figure 5.1, draw 3 wavefronts after the wave has passed through the gap. Okay, so this is the wavelength, the distance between the two wavefronts. And if you look at this gap is either equals to this wavelength or is smaller than that. So when these wavefronts, which are straight wavefronts, when they will pass through this gap, what will happen? They will convert into perfect semicircular wavefronts. So they will convert into circular wavefronts. So how I will draw them? I will open my compass, and I will open the compass equals to this wavelength. I will put it here in the center. I will draw a semicircle. Then I will open the compass equals to 2 wavefronts. I will put my needle of the compass in the center, and the compass will be opened with a radius of 2 wavelengths. I will draw another semicircle. Then I will open my compass equals to 3 wavelengths. I will put the needle of the compass in the center of this barrier, this gap, I mean, and the compass will be opened equals to 3 wavelengths. And I will draw another wavefront. So in this way, I will draw semicircular wavefronts. You see, the one thing is very important. When the wave will pass through that barrier, the wavefronts, which are straight wavefronts, they will convert into semicircular wavefronts, and the wavelength will not change. So one of my students, she has drawn these wavefronts, and let me show you that. So here, can you see this diagram? And hopefully this is okay. So she put the compass needle here, she draw that, and then she open the compass equals to 2 wavelengths, she draw this semicircle, then she open the compass equals to 3 wavelengths, and she draw this. So perfect semicircular wavefronts, and you can see that the wavelength has not changed. So this is how you do this, and let me show you the marking scheme. Here is the marking scheme of this. So you can look at the 5A. Okay, now we are going to, so this was red light. Remember, this word is very important. He said this is red light. So, you know, the red light, and then in the B part, he says, figure 5.2 shows the same barrier and gap. A wave of the blue light approaches this barrier. So, so now we are talking about the blue light. You know, the blue light, its wavelength is smaller. The blue light, its wavelength is smaller. So first of all, I have to draw here the wavefronts. Draw 3 wavefronts of this wave before it reaches the barrier. Draw 3 wavefronts after the wave passes through the gap. So, you know, the blue will have a smaller wavelength. So because the blue will have smaller wavelength, so I will draw wavefronts here, which will be of the smaller wavelength. So can you see this? These wavelengths, they are larger. These wavelengths, they are larger. When this diagram has been drawn by one of my students, so when you draw these wavefronts, you see they must be perpendicular to these direction lines. And this gap between the two wavefronts should be smaller because the blue light has a smaller wavelength. So now because this wavelength is smaller, so this gap is larger than this wavelength. When the gap between the barrier is larger than the wavelength, then what happens on the ends near these ends of this barrier, the light bends, the wave bends, but in the center the wave remains straight. So this diagram is not of that good quality, but here on the edges it is bended, and but in the middle the wavefronts remain straight. So on the ends it bends, but in the middle it is straight. And one thing which is very important is that this gap, the gap between the wavefronts, must be equals to this wavelength. This wavelength after the barrier and the wavelength before the barrier should remain the same. So I hope you understand there are two very important things. They were talking about red light in the first part, and then they talked about the blue light. And one fact which you should remember, they have not told in the question that the blue light has a smaller wavelength as compared to the red light. And when the gap between the two barriers, the slit, the gap in the barrier, if it is larger than the wavelength, then what happens in the middle of the wavefront remains straight, but the ends, they bend. So this is how you got this diagram and this diagram. And this question is very important. This is the topic, diffraction of the waves. And this is one of the new topics which has been added into the Cambridge syllabus. So you can look at the marking scheme. I hope if you want to take more time with this marking scheme, you can pause the video and take your time. And this is how this is done. This is the A part, this is the B part. So everyone, thank you very much for taking out time and watching this video. If you like this video, please share the link of this video with your class fellows, with your junior students, and with your teachers. Also, like this video. Please subscribe to my channel. Also, share the link of this video on your WhatsApp groups and on your Facebook, on your TikTok, on your Instagram, uh, on your X. So whatever social media you are using, please share the link of this video on your social media. When you do this, actually what happens, you support my channel, you support me. When you do this, I can continue doing this tremendous work. So I hope that this video will be very useful for you. So keep working hard, keep learning, and keep striving. You will be successful. Thank you very much. God bless you.